Hi guys, in this video we've got a very ambitious goal. We want to set up HTTPS on our website. Right now our website is working over HTTP unencrypted. That means if we would add any kind of form, the data from that form, the data that user is sending to the website or the website is sending to the user, this data is super easy to sniff. So anybody who sits in between the user and the website will be able to see what we're sending. We don't want that. We want us to be a little bit more secure, and that where HTTPS comes into play. The best thing about it is that Nginx will be handling most of HTTPS heavy lifting, and Node.js application will not even need to know that we are now encrypting our traffic. So this will be the picture that we're coming to, Nginx handling all the HTTPS and then talking to Node.js through plain old HTTP. We don't need to secure this internal part because internally no one will be able to intercept our traffic within the same host. In order to enable HTTPS on our website, we will first need to get an SSL certificate. So what is an SSL certificate? An SSL certificate is a little file that allows your end users to check that you are indeed a valid website. So you are indeed connecting to the right website and no one else will get the credit card information, for example. So if you go to something like wikipedia.org, that is HTTPS, right? You will see here the green lock. That means that Chrome is trusting this website. What Chrome did to trust this website? It checked that the certificate is valid. So if you click here, view certificate in the security tab of your developer tools, you will see who issued this certificate and what are the details of this certificate. So that's pretty much what the certificate is all about, and we will need to get one for our website. So who can give you the SSL certificate? It must be a certificate authority. We will be using Let's Encrypt, as I mentioned before. There are two major reasons why we are doing it in this video. First, it is totally free. You will not have to pay any single cent or register anywhere in order to get that certificate. And the second great reason is that Let's Encrypt, they have this special tool called Certbot that allows you to create and verify the SSL certificate with almost no effort on your server. So in this video, we will learn how to use Certbot to get an SSL certificate from Let's Encrypt, and afterwards we will see how to install that certificate on Nginx. So let's start. We will need to SSH as root to our server because we will be installing new software here. And the first thing to do is to make sure that we have Apple or EPEL repository installed and enabled on our system. So if you were following videos, you probably remember this command, yum install EPEL release, right? So we used it to install Nginx before. If you just jumped into this video and you're watching from this very moment, make sure that you run this command, but I don't need to run it because my EPEL release is already there. And the next thing to do is to install Certbot. Let's do that. Yum install Certbot. So it will take a couple of seconds to install. This is a rather small package, so it shouldn't take much. And now Certbot is installed. Now the next thing to do is to request a certificate, and Certbot will be pretty much doing all the heavy lifting for you. We just need to start it with the right command line argument. So Certbot, we will just need a certificate, cert only. What that means that we don't want to install the certificate automatically. Certbot can also make sure that your configs and Nginx is updated properly or Apache web server is updated properly to have that SSL enabled, but we will do that by hand. We just don't want Certbot to mess with our configs because, well, we like to mess with our configs ourselves. The next parameter to add is standalone, and it means that Certbot will use its own standalone web server to pass the process of verification of this domain, basically to prove to the authority that we are indeed having the control over this server and we're not trying to generate the certificate for some server that doesn't belong to us. And finally, we will need to pass the domain name. So we pass -d and we tell nanogram.io. So that's it. Let's hit enter and see what happens. So enter email address, right? Certbot will register your email address, and when your certificate will be expiring, you will have an email reminding you that, well, it's worth renewing it. So I will type my email here and hit enter. So terms of service. Obviously, I agree with terms of service. Finally, will you be willing to share your email address? Yeah, I don't mind to share my email address. Of course, you can choose whatever you like to do with your email address. Now we're obtaining new certificate, waiting for verification, and almost there. Awesome, we've got a certificate, and these important notes, they are really important, so let's not just dismiss them straight away. Let's read what they say. Your certificate and chain have been saved at this path. So in my case, it's @C, Let's Encrypt live. This is your domain name. So if you're working with your own domain, you will have your domain name here, and fullchain.pem. Okay, so your certificate will expire at this time. So we will be able to renew this certificate. I will show that in a separate video. Finally, a super important notice. Your account credentials have been saved in your Certbot configuration directory at this path. You should make a secure backup of this folder right now, right? And this is super important. So make a full backup of your Let's Encrypt directory because it has both the key and the credentials that you will need to use later. So this is exactly what I will do right now. I'll make a backup copy of this folder. So I want to copy everything from @C Let's Encrypt to the home folder of our secure user. That should be good. And let's go there into home. Here we've got Let's Encrypt folder. And now let's just compress it to have a single nice file that we can download to a safe location. So now my secure backup is here. Let's encrypt tar.gz, and I can safely fiddle with my certificate without being afraid to lose some of them. Don't forget, download this file and keep this secure. This is important. Now let's go and edit our Nginx config file to make Nginx aware that we've got now certificates and we want to use HTTPS instead of just HTTP, and it's in /etc Nginx confd, and here's our nanogram IO conf. Now here comes a little bit of a tricky part. Ssl configuration is not a trivial subject at all, and if I would start to explain each and every parameter that we will be using in a config, it would probably take like 10 more videos in its own, right? So there are multiple ciphers and algorithms that are used between a client and the server in order to set up the secure communication protocol. This is a very important and interesting subject, so if you are interested in these aspects, I will leave you links to go deeper and to start learning about cryptography and SSL. However, this subject is way outside of the scope of this video. So in this video, I will be focusing on the recommended configuration. And in order to get that recommended configuration, the best probably tool right now is the Mozilla's server-side TLS tool and SSL config generator. So all you need to do is to open this link, and again, I will leave the link in the description to this video, and give the details about your server configuration, right? So we are using Nginx, and we will probably not go with modern configuration because it assumes like IE11, which is like really modern. We still might want to cover a little bit more outdated devices, so we'll go with intermediate configuration. And finally, we need to put here server version and OpenSSL version. So the server version, how we get it? Let's go out of our config and type Nginx -v. This is our server version. It's 1.10.2. Let's go here and update it to 1.10.2, hit enter, and here is your configuration. Now we will need to take this block, the server block with 443, and copy it to our config and then edit it a little bit to match our settings. So I'll do that right now. I'll copy that. Now I'll go back to Vim, to our config file. So let's insert it right after our server block that describes our normal HTTP, our port 80. So I'll insert it here, and as you see, this config is quite big. So let's try to quickly go through this config and fix it a little bit. So HTTP2, I'm not touching HTTP2 at all, but okay, let's just leave it as it is. Mozilla recommends it, so we're fine. SSL certificate. SSL certificate is the path to your certificate that we generated. And the path will be like the following. So it is in /etc Let's Encrypt live. Then goes your hostname, nanogram.io. Then the file name is fullchain .bem. Okay, so this looks good. SSL certificate key, so this is the path to the private key. This part of the path will be exactly the same. So I'll copy that. And the file name will be privkey.pem. These settings, we just leave them as they are right now. The next parameter, we will not touch it in this video again, because it will require you to generate some additional parameters for a better encryption. SSL protocols and ciphers. This tells the priorities in which Nginx will prefer certain protocols and the list of the ciphers that will be supported. Besides, we say that whenever we're negotiating SSL ciphers, we will insist on server-side preferences rather than on client-side preferences. Again, this will increase the security. So the following line is used for OCSP stapling, and we will not do that in this video. Again, feel free to read more about it. We will not enable it in this video. And resolver, the DNS resolver, will point it to Google's DNS address. That will be quite safe. Okay, awesome. So our configuration looks good right now. It's a little bit cryptic, but still, you just need to add a couple of arguments. SSL certificate, SSL certificate key, these are the two that you need to worry about. All these guys are just copied as they are, and resolver just pointed to 8888, and that will be just good. SSL stapling, yeah, just let me remove these ones as well. Now let's try to just serve static files from HTTPS and see if that works. And to do that, I'll copy server name and root directives from our server configuration for port 80, and I will just insert them as they are into the configuration for our SSL enabled config. Okay, so let's make it nice and clean. Now, moment of glory. Let's go and do systemctl restart Nginx and hit enter. Okay, so it's restarted quite fast. Now let's go and check how our nanogram works with HTTPS. So I'm typing here HTTPS explicitly, and I'm going to nanogram.io. Let's hit enter, and you see here it's green, it's secure. So far we're not passing anything to our backends because we are only serving the static files. But now Google Chrome is happy, and that means that we configured Nginx properly. We can even go here to the security tab and read a little bit about our certificate and figure out what is this certificate like and who issued it and when it expires, etc. So awesome. Now the final part is to transfer all the rules about our HTTP headers and the reverse proxies that we use for socket IO and for the API calls, and move them from the server that is responsible for port 80 to the server that is responsible for HTTPS for port 443. So let's select this line, everything started from proxy set header and everything down, all the way to the error pages. And we're removing it from this block. Why do we remove it? Because we will not use unsecured HTTP at all. Later I'll show you how to redirect all the traffic from port 80 to port 443 using HTTP redirect. But for now, let's just copy them, right? Okay, so we took this part of config. Let's go all the way down, and right after resolver, we are inserting this part of the config. So proxy set headers, all the real IPs, socket I rules, API rules, and error pages are all now transferred to HTTPS part of the config. So now let's save it and restart Nginx again. Let's see if that works. HTTPS nanogram IO, we've got round trip time showing up. That means that socket IO is working now over HTTPS. We've got proper XHR working, so all the responses are there and the IP addresses are also saved. Now finally, what we need to do, we need to send everyone who's trying to access something on port 80, we need to send them to port 443 so that no user will be able to access any contents that is unsecured. And to do that, we can go back to our Mozilla tool. And this part has this line, return 301 HTTPS host request URL. So this will do 301 redirect to HTTPS, to secured version of our website. So that's what we will do. We will take just this line, we'll go back to our server config. We don't need root here anymore. We're not serving anything at all. And we will insert this line right here. Let's paste it. So we're returning 301, and now everyone will go to HTTPS of the same host with the same URI. Okay, let's save and quit. Let's restart Nginx. Now let's see what exactly server is sending us. To do that, we will do curl and we'll ask it to be verbose, and we'll ask for nanogram.io. This way it will print the required headers. And you see there is no content, right? It's just HTML page that says 301 moved permanently. And where it moved to a header location part, right? So it moved to location HTTPS nanogram.io. So whenever you're trying to receive something from this page, it will send you to this page instead, which is secured. Congratulations, we just secured our website. I must admit this was a bit difficult tutorial, but I hope that we went through this tutorial just fine. I will post the full configuration that I used in this video on GitHub, so you can copy-paste the parts of those configs that will be applicable for your server. And now your users will be secure. Whenever they are sending some personal details, it will be extremely hard to sniff them over the network. So thank you very much for watching. Don't forget to subscribe and press that like button, and see you in the upcoming videos. Bye!